the first equation. So if we look DAB, it has no, it's 0, so that's no value for A. Then for B, actually, for density, there is a value, so it's going to just be B. And then for C, which is assigned to the diameter, that's no value, it's 0. So that means B, it's just B is equal to 0. Oh, and then obviously the mass transfer coefficient is also 0 here. So then it's only the B value, which is equal to 0. Now let's look at distance. So that is going to be 2A, since it has a value of 2 for the first component. Then for density is minus 3B. Oh my God, minus 3B. And then for distance is 1, so plus C. And then KC is actually 1 too, so it's plus 1, and that is equal to 0. All right. Now for seconds, for time, it's going to be, so minus 1, so minus A for the first component. Then B is going to be density. There's no density, it's 0 here. And then for the diameter, it is also 0. And then for the non-core group, for our mass transfer coefficient is minus 1. So minus 1 is equal to 0. Now we have all the components of to solve the equation. So to write out the general format of the equation, I mean. So now that we have the components. So A, we know, is just minus 1. Minus 1. B is equal to 0. And then C is equal to, so it's minus 1, minus 1, minus 2 equals 1. So C is equal to, so 2A minus 2 minus 1. So C is equal to 1. Okay, so the general format of this equation would be pi 1 with, when we incorporate the exponents, it would be over DAB, and then there is no density, so it's just going to be diameter times KC. So that is our first setup of the equation for dimensionless group. And then, interesting thing about pi 2, since we're going to look at the non-core group, right? Because it has the same format of the core groups, but the non-core group is what creates the discrepancy between 3 of them. So this velocity here has the same unit as the mass transfer coefficient, which is meters per second. So since it has the same unit, it is basically the same setup of this equation, with exception to it not being the mass transfer coefficient, but the velocity. So that's why we don't have to do this whole thing again, since it's the same thing, except we're doing DEF instead of ABC, but it doesn't matter because we have the same format of the equation, just velocity and not the mass transfer coefficient. So it's just going to be D times V in this case over the mass diffusivity. So that is the second pi equation. Now let's do the third one, which is the same method of doing the same method as we did for the first pi equation. So again, kg meters second. So in this case, we're dealing with values of GH and I. So yeah, so now we're going to look at, so second equation. So okay, again, DAB, nothing for G. So for H, which is assigned to the density, is going to be H. And then in this case, no value for the diameter either. So then we're just going to look at viscosity, and that is 1. So H plus 1 is equal to 0. And then we have, now we're going to look at distance. So in this case, DAB has a value of 2. So 2G minus 3H, because minus 3 is assigned to the density, and then plus 1 for the diameter, so plus I, and then we're going to look at the non-core group, which is the viscosity in this case, and that is minus 1. So minus 1 is equal to 0. And then now let's look at time. So it's just same thing here. So minus G, and then we don't have anything for density or diameter again. And then now let's look at our non-core group, which is minus 1. So minus G minus 1 again, which is equal to 0. And now let's solve it for all H, G, and I. So H is minus 1. G is equal to minus 1 again, and I is actually equal to, so if we do this, minus 2 plus 3, minus 1, so I is equal to 0. And then now we have that pi 3 is equal to, if we put it in this form, it's going to be equal to DAB, it's going to be over DAB, I mean, with the mass diffusivity, times the, so that is also is a G and an H, so over the rho, it looks like a P, but rho, and then viscosity is at the top. So that's after simplifying and everything. So now that we have the equations of pi 1, pi 2, and pi 3, now let's actually see if the Schmidt and the Sherwood and Reynolds number are the correct dimensionless groups. So I can write it down, just enough space, actually right here, I'll write it down here. I'll put an arrow here so it's better to look at. So now, by definition, pi 1 is equal to the Sherwood number. Pi 2 is equal to this thing called the I think it's called the Pleckett number, so, or Pecklet number, PD, and then pi 3 is the Schmidt number. So if we do this, if we try to find if they're the correct dimensionless groups, let's do pi 2 over pi 3, Pleckett number over the Schmidt number, and then that is pi 2. So pi 2 is dV over dAB, and then mu over dAB times rho. So dAB cancels, and then look what we have here. We have that dV times rho over mu. And what is that? That is the Reynolds number. So since that's the Reynolds number right there, we can say that the Sherwood, Schmidt, and the Reynolds number are the correct dimensionless groups. And that is the end of part 1. And we can now go on to part 2, which is the coding. Thank you.